Hey guys, Mr. McKinney here, just going through our trig version of extreme values. And we'll be primarily focused on trigonometry. We won't really get into exponentials or logs because if you think about the graph of e to the x, and if you think of the graph of ln of x, they're not very interesting graphs. They don't have very many extremes. The only extremes, the maxes or mins that you would get would be if you had endpoints, because the exponential graph is always increasing, as is the logarithmic graph. So this lesson will be primarily focused on extreme value problems and point of inflection problems with trig. This is going to go fairly quickly, so if you need help, go back to Unit 5. Today's lesson is basically redoing the majority of Unit 5. All right, so I've copied and pasted this slide from my own slideshow. That's why it looks a little bit different. If you don't have this summary table in your notes, I highly recommend that you put it in there. When we talk about extrema, we're talking about maxes and mins. The first derivative is going to help you find maxes and mins. So the first derivative will either be equal to 0 or it won't exist. If that's true, you have a critical point. That's a possible extrema. You have to look to make sure that the sign has changed. If you don't have a sign change in the derivative, you might have something like this. So the slope is 0 here, but I don't have a max or a min because the slope was positive, 0, positive. So in order to have a max, you have to have a slope that's positive to negative. In order to have a min, you have slope that's negative to positive. So the first derivative is going to help you ask questions about max or min. Later on, we'll talk about the second derivative, which helps you answer questions about concavity or points of inflection. So the first part of this video series will be focused on extrema. Okay, so you should already have these in your notes. If you don't, copy them down again. For absolute extremes, we're talking about the absolute max and the absolute minimum. So the absolute max is the absolute highest number. It must be a concrete value, so you can't have infinity as your absolute max. Same thing with the absolute min. It's the absolute lowest. Make sure that you check endpoints in addition to these places where you might have a local max or a min. So make sure you check the endpoints. That's the other possibility for absolute maxes and mins. So it's at the endpoints or where the local maxes and mins are. So if we think about the sine function and we want to find the extremes, and remember if it asks you to find the extremes or the extreme values, it's looking for 4 things. It's looking for a local max, a local min, and again, local is the same as relative. And then it's also going to ask for an absolute max and an absolute min. Another name for absolute is global. So if you see relative or local, those mean the same thing. Global or absolute, those mean the same thing. And whenever we ask for an extreme, we're asking for the y value because that is the actual max or min. Now the sine function bounces back and forth between 1 and -1. So my local max is 1, and it happens at a bunch of different places. Pi over 2, and then 5 pi over 2, -3 pi over 2. So it'll happen at lots of places, but the extreme is just what is the y value at the max. Now, it's the same, if we don't have any endpoints, the absolute max is going to be the same as the local max. Even if I put endpoints on this one, as long as I went through a full cycle, it'd be the same. The only way the absolute max or min would be different is if I cut off the cycle and just said, what's the absolute max and min between here? Then it would be one of the endpoints. So my local min would be at -1. So this is just looking at a graph. We'll do a problem algebraically in a little bit. Now, if we think about the cosecant function and we think about the extremes, so local max, local min, absolute max, absolute min. So these values are at 1 because these are the peaks of the sine function. So cosecant is 1 over sine. So if you think about it, we're just drawing a sine function. Wherever sine is 0, you have an asymptote on the cosecant function. When sine is 1, cosecant is also 1. Now, where 1 was a local max for sine, 1 is going to be a local min for cosecant. And -1 is going to be a local max. So notice how the local max is actually lower than the local min. So it's just local. So it means in that area it's the highest point, or in that area it's the lowest point. Since we have arrows that are going up and we have arrows that are going down, we don't have an absolute max and we don't have an absolute min. The only way we could get an absolute max or min was if we had put a domain restriction on this and maybe we were only looking between like this point and this point. Then we'd have an absolute min and we'd have an absolute max. All right. Now realistically, you'll probably be doing this type of problem with an equation. And so to solve an extreme value problem, when you have an equation for f of x, you're going to take the derivative and you're going to look for where that derivative is equal to 0 or it's undefined. The vast majority of problems that we're going to be dealing with is going to be when the derivative is 0, but you also need to be thinking about where it could be undefined. Primarily that would be happening if you had like a cusp or a corner. So your max or min, the derivative would not be undefined at a cusp or a corner, but it could be a max or a min. We call these points critical points as long as they're not endpoints. So if the derivative is equal to 0 or the derivative does not exist, then we have a critical point. A critical point is a possible extreme. You have to check and make sure there's a sign change. Excuse me. All right. It's also called a stationary point if it flattens out. That just specifies the difference between equaling 0 and does not exist. This is primarily just to help you answer some questions on Math Excel. I don't think the AP exam will ever reference stationary points. All right. So if I want to find the extremes, I know I'm asked to find maxes and mins. I need to find 4 things: local max and min and absolute max and min. Since I have endpoints, I'm going to have to check those endpoints as well as any place that the derivative is equal to 0. So the first thing I'm going to want to do on this function is find the derivative. Now before I do that, I'm going to rewrite cosine squared of x so that it's a little bit easier to see. So I have not taken the derivative yet. 2 sine of x minus cosine of x squared. All right, so now when I take the derivative of 2 sine would be 2 cosine of x, and then the derivative of cosine squared, so I'm going to do the power rule first, 2 cosine of x to the first power, and then the derivative of cosine, which is negative sine of x, and then the derivative of x, which is 1. So these two negatives are really going to become a positive. So the first derivative should be 2 cosine of x plus 2 cosine of x sine of x. All right, so now we want to figure out where the derivative is 0 or undefined. Cosine and sine are defined everywhere, so I just need to know where this is equal to 0. So the first thing I'm going to want to do is make sure at some place I write f prime of x equals 0 to show the AP reader that that's how I'm going to find my extreme values. For this one, if I want to make the derivative equal to 0, I'm going to want to pull out 2 cosine of x, and if I factor that out front, I'd have 1 plus sine of x left over on the inside. If I have 2 factors that multiply to be 0, I know that either 2 cosine of x is equal to 0 or 1 plus sine of x is equal to 0. So cosine of x equals 0, x equals cosine inverse of 0. A lot of times I just like to draw a cosine function to remind myself. So pi over 2 and 3 pi over 2 are the 2 values on this interval where cosine is going to be 0. And then 1 plus sine of x, so I want to know when sine of x equals -1. So I want to know what the inverse sine of -1 is. So this was my cosine graph. A sine graph, I'm asking when is sine at -1? And that's going to happen at 3 pi over 2 as well. So 3 pi over 2 showed up in both of these equations, but I only need to put it into my table once. So the values that I need to put into my table are 0 and 2 pi at the endpoints, and then pi over 2 and 3 pi over 2 on the interior. So when I make my table of values, I need to have a row for x, and then I need to have, well, let's do x on the top. So x, f of x, and then f prime of x. So x is going to start at 0, leave some space. Make sure I put these in order. So pi over 2 needs to come next, leave some space, 3 pi over 2, leave some space, and then 2 pi. Even though 2 pi is not actually included, I need to check it because sometimes the endpoints might make it so that one of the other values is not an absolute max or min. Go back and watch the videos from Unit 5 if you don't know what I'm talking about. So we can fill in the derivative. We know that the derivative is 0 at pi over 2 and 3 pi over 2. That's what our math told us. So now I'm going to check if I plug in a number that is less than that or greater than that or in between those. So let's think about pi over 4. So cosine of pi over 4 is a positive value. Sine of pi over 4 is also a positive value. 1 plus that is going to be positive. So positive times positive would be positive. Now in between here, let's think about pi is in between here. So cosine of pi is a negative value. Sine of pi is 0. So 1 plus 0 is 1, but cosine was negative. So that's going to make this a negative value. And then in between 3 pi over 2 and 2 pi, cosine is positive. And then sine in between 3 pi is negative, but if I add 1 to it, it's always going to become positive. 1 plus sine is always going to become positive. So I've got a positive times a positive. So again, that's positive. I just need to check on either side. If I go from my slope being positive to negative, that tells me that this value right here is going to be a local max. And when I go from negative to positive, I'm going to have a local min. Now, I need to plug in these 4 values into the original equation. So 2 sine of x minus cosine squared of x. I'm going to go ahead and do that. Okay, so just to save time, I went ahead and filled those in. So again, just plug each of these x values into the original function to get these yellow values. So then I have to come up with my 4 answers for the extremes. The local max, local min, absolute max, and absolute min. You can have more than one local max or min. You can only ever have one absolute max and min. In this case, the local max, so local max I had here was 2, and then I check 2 is the largest number, including the endpoints, so that's also my absolute max. My local min was -2, and then I check -2 is lower than the endpoints, so that's also my absolute minimum. So again, the way that you can show that it's an absolute max or min is show that the first derivative goes from positive to negative at a max and negative to positive at a minimum. You don't need to plug in all the values for f prime. You just need to show whether it's positive or negative. You need to plug in the f of x values at the endpoints and at the critical values. All right. So why don't you guys try this whiteboard problem? It's very similar. It's got a trig function squared and then minus cosine instead of 2 sine on the previous problem. So go ahead and try to find the extrema. So find the 4 extremes and then see how you do. All right, let's see how you do. So you find the derivative. You should get -2 cosine of x sine of x plus sine of x. When you set it equal to 0, you end up getting 3 values that you need to add to your table. So you would factor this one and have sine of x times -2 cosine of x plus 1. And when you set that equal to 0, the sine of x equaling 0 would give you 0 and pi. You already have 0 in your table. And then when you set this equation equal to 0, you get cosine of x equals 1/2. That's where the pi over 3 and the 5 pi over 3 come from. So then plug those values into the original function to get the top row, and then use the derivative to fill in the pluses and minuses in between your zeros. Notice that the absolute max and the local max both happen, and they're 2 at the same place. Same thing with the minimum, and they're -1/4. You don't have to specify where, just what. All right, that's it for the first video.